So my talk will be on social cognition deficits and neurodegeneration, and also from my side, I'd like to thank the organizer, or the organizers, but not only you, for inviting me. My talk will be divided in two parts. The first one is on frontotemporal dementia, and the aim of that part is partly to raise some awareness about this rare disorder, but very fascinating and intriguing disorder, especially regarding social cognition. And the second part is a case study on a patient also with neurodegeneration and who has a misidentification symptom. And that was particularly, or I included this when I saw the subtitle for the workshop, which also includes, which states that it goes from self-knowledge to knowing others. So the last part is about primarily self-knowledge. To give you a bit of an impression of what a patient with frontotemporal dementia might present with in the clinic, I will read you a case history. A 60-year-old male came for assessment of a progressive behavioral deterioration. 3 years earlier, this previously successful businessman began to have trouble meeting his sales quotas. For his 30th anniversary at age 59, he bought his wife a battery. He became distracted and remote and lost interest in sexual relations. On visits to a family counselor, he resisted discussing his feelings. Whenever asked about whether he was depressed, he repetitively noted that he couldn't feel better. He began to use words in a stereotyped manner and often repeated, "That's part of the puzzle." Drinking at home became common, and he was found intoxicated on the day of an important sales meeting. After counseling, he entered an alcohol rehabilitation facility. The drinking stopped, but he began to smoke 2 packages of cigarettes daily and started to overeat, gaining 20 kilograms. His wife complained that the psychiatric facility replaced one addiction with 2. After returning to work, he failed to return calls from clients and rarely left his office. Papers accumulated on his desk, and he kept a collection of cans in his closet. After counseling and a probation period, he was fired. He worked for less than 1 month delivering papers by bike in his community, but delivery was erratic and he lost this job as well. Seemingly undisturbed by his misfortune, he spent most of the time at home watching television. He drove through red lights and lost his license after he was arrested for driving 70 kilometers an hour in a school zone. He became more withdrawn from friends and family and began collecting cans from the garbage to sell. Although no longer interested in sexual activity with his wife, he brought pornographic magazines to the house and enjoyed showing them to his wife's friends when they visited. His eating dramatically increased and he developed a craving for hamburgers, eating 6 every day. On examination, the patient was restless and often left the room to pace or go to the bathroom. He was disinhibited and commented on the female neuropsychologist's breasts and asked for a kiss. Didn't have any patients yet commenting on my breasts, but this is to give you a feel about the type of the clinical phenotype that we see in a clinic of patients with frontotemporal dementia. And so several key characteristics are associated with this disorder, and guess what? Frontotemporal dementia is associated with atrophy of the frontal and the temporal lobe. There is quite some variability in this brain atrophy, where some patients may have primarily frontal or primarily temporal, and then particularly anterior temporal, atrophy, and there's also quite variability in lateralization with particular patients, for instance, displaying primarily atrophy in the right anterior temporal lobe. It's quite a rare disorder, so it only constitutes about 2% of all dementia cases, compared to Alzheimer, for instance, which make up 70% of dementia cases. And there are quite some estimates about the prevalence. They range between, for Belgium, 2 per day to 1 in 3 days. But in Leuven, our clinic, we were able to include in our studies about 10 patients per year. This does not necessarily reflect the prevalence of the disorder, because this clinical phenotype is, of course, one of the most challenging populations to include in scientific studies because of the personality changes and the symptoms. Although it's quite rare, this disorder, it's the most common disorder in patients with dementia before the age of 60. So about 1 in 2 patients with young onset dementia, they suffer from frontotemporal dementia. Also, for instance, Bruce Willis, who recently was a lot in the media with his aphasia, actually is diagnosed with a case with primary progressive aphasia, which is one of the main 2 variants of frontotemporal dementia. So there are the primary progressive aphasias, which constitute, of course, the language problems, and these include both the speech problems as well as the semantic difficulties. And the other phenotype is the behavioral variant dementia, frontotemporal dementia, which, as you may guess, is primarily associated with changes in personality and behavior. And these syndromes, they may start, what's primarily differentiating between them is what constitutes the first symptom. So either a language problem or a behavioral problem. But as the disease progresses, these phenotypes, they may converge. And also what is characteristic for particularly behavioral variant frontotemporal dementia in the early stages are also the social cognition deficits. It changes in empathy, emotion recognition, mentalizing, all these kinds of things, as we also heard from the case history. So why is it also such an interesting disorder? Not only because of the clinical phenotype and the associated social cognitive disorders, but also on how this brain atrophy spreads across the brain. So here you see image of several neurodegenerative disorders, and what you see on top here for behavioral variant frontotemporal dementia, if you compare the structural MRIs of patients with BV-FTD with healthy controls, then you can see that the brain area with the largest difference in gray matter volume is the anterior insula. And what this slide shows is, if you compare that with, if you use this region as a seed for and you calculate intrinsic functional connectivity in healthy controls, then you get this result, and which is very similar to the atrophy pattern that you see in the VFTD. And at the bottom row, you see the structural covariance networks in healthy controls. So these maps, they reflect how much the gray matter volume of brain regions over subjects correlates across regions. Here you see this is the primary region of atrophy of semantic dementia, which is one of the behavioral, language variants of FTD, and here progressive non-fluent aphasia is another language variant. And on the right, you see a bit more detail of the BV-FTD patterns. And what these slides show is that the atrophy or the diseases, the neurodegenerative disorders, they target large-scale brain areas. And this is the hypothesis for the nexopathy proposal that the spread of molecular pathology in these disorders, they follow the architecture of the intrinsically connected network. So in 2011, the first diagnostic criteria were reported for behavioral variant frontotemporal dementia, and these consist at least 3 of 6 symptoms in behavioral disinhibition, apathy, loss of empathy, compulsive behavior, hyperorality, and dietary changes. There is also a cognitive diagnostic criterion which states that executive deficits should be the main cognitive deficits, and the memory and visual spatial functions should be relatively spared, but there is an accumulating evidence against this criterion. And there are 3 levels of certainty for the diagnosis. And so if a patient presents with a clinical phenotype that adheres to this criteria, then we speak of possible BV-FTD if there is supporting imaging findings, so either MRI or FDG PET, they show abnormalities in frontal and or temporal regions, then we speak of possible BV-FTD. And there are also cases of definite BV-FTD, and this can either be because the patient is carrying a genetic mutation that is a known pathogenic cause of the disease, as Jazé presented earlier today. Or the other possibility of a definite diagnosis is when post-mortem the brain biopsy reveals that the typical molecular histopathology associated with BV-FTD, which is of course not possible to investigate in vivo. There is quite some overlap also with primary psychiatric disorders, and there's an exclusion criterion for the diagnosis of BV-FTD if the phenotype is better explained by a psychiatric disorder. So, regarding social cognition in the field of FTD, it has been primarily investigated in 3 subdomains. So, emotion recognition, typically investigated using facial expressions, as we have already seen a couple of times today. Theory of mind, also relating to the inference of other person's thoughts and intentions, and then empathy, which is really something quite difficult, I think, to investigate, as it primarily refers to a feeling, and it's not so easy to measure a feeling. And typically we do this in FTD diagnostics by including questionnaires for the caregiver. Because often the patients with BV-FTD, they also show anosognosia, so they are convinced that they don't have any problems whatsoever. And it's not uncommon that they try to convince the clinician and the healthcare workers that they are fine. So also a bit relating to Arthur's talk this morning, the assessments that we perform to investigate emotion recognition in patients with a suspected BV-FTD disorder. These include, we use this typical matching task, indeed, to avoid as much as possible verbal processing, and the task here is to indicate which of the 2 bottom pictures, so we use, for instance, body expression, but also facial expressions, which of the 2 bottom pictures matches the top one. And we also have a control task with, where the task is to match the identity instead of the emotion. And these are the types of tasks that these patients typically fail on, even more so than other neurodegenerative disorders, primarily Alzheimer's disease. What we then often do in our studies is, if we do behavioral tasks like these in emotion recognition, we can correlate their performance with a structural MRI to investigate which brain regions, or where in the brain does the volume of the gray matter correlate with behavioral performance. And what we found here using these tasks is here in the frontal insula or anterior insula, that we see a clear association between emotion recognition performance and gray matter volume in FTD. What we also do in our group is we use fMRI in cohorts of patients with FTD, and there are only like 5 labs who do this or who have done this so far worldwide, because it's such a challenging population to include for research studies. But one of the interesting things that we can do with fMRI in these disorders is that we can also include the brain structure in our analysis. Whereas in most fMRI studies in neurotypicals, we can look at the brain activation, but in FTD we can also look at how activation and volume, for instance, correlate. And in one of our studies, we presented facial expressions to patients in the scanner, and then we defined, the face, the classical face regions, the fusiform face area and the posterior superior temporal sulcus. And what we can do then is correlate the brain activation in these regions with structural measures, so with gray matter volumes in our BV FTD cohort. And there, for instance, what we found is that the volume of the amygdala correlates with the emotion response in the fusiform face area. So the most commonly used task to assess mentalizing or theory of mind is the faux pas test, and it consists of stories. For instance, the patient then has to read the story. Jill had just moved into a new apartment. Jill went shopping and bought some new curtains for her bedroom. When she had just finished decorating the apartment, her best friend Lisa came over. Jill gave her a tour of the apartment and asked, "How do you like my bedroom?" "Those curtains are horrible," Lisa said. "I hope you're going to get some new ones." And after reading the story, then we ask the patient if somebody said something they shouldn't have said, or if somebody said awkward, and how the people felt in the story, and so on. And these are typical also tasks that are very difficult for patients with FTD. And also here, others have investigated the structure of brain correlates of performance on this task, and have found that particularly the anterior temporal lobes here, the TPJ, the volume in those regions correlates to the performance on this task. And as I said about the assessment of empathy, we often turn to the caregivers of the patients, and we ask him or her, this is typically the partner, to fill in questionnaires on behalf of the patient, or how they perceive the patients. And one of the questionnaires that is often used is the interpersonal reactivity index, which was also discussed in the previous talk. And another one, is the revised self-monitoring scale. It consists of several subscales. I don't know if you can read this, but for instance, the first question says, in social situations, the subject has the ability to alter his behavior if he feels that something else is called for. So the question about how sensitive the patient is to socio-emotional cues, and how well the patient is able to alter his or her behavior if it is requested, or if it is advantageous in a particular situation. And also here, a recent study in a sample of BVFTD cases, what they did here is they correlated, it was a longitudinal study, and they correlated the change in the score on the revised monitoring scale with the change of gray matter volumes, and also here the orbitofrontal cortex, but particularly the anterior insula. There's a pre-metaphorium that was associated with these regions. So these are tasks that are used in the clinic, and the clinicians may know how limited the time is to conduct a neuropsychological examination in patients, and social cognition is often not even assessed in the majority of clinical settings. So it's quite difficult to, there is a consensus in the field that there is a need for very efficient social cognitive tasks. And some ambitious endeavors have been undertaken with a classical task, which was, of course, you cannot do in a diagnostic workup, but in the group in UCSF, they use a karaoke task to investigate self-conscious emotions in a FTD. And this task consists of asking patients or persons they come to the lab, and they are required to sing a karaoke song. And while they do that, without them knowing, they are videotaped. And when they finish the song, it was the song "My Girl" from Temptations. You're interested? After they finished the song, they were they were instructed to watch the screen, and then immediately after this, they sang the karaoke. The video was played of themselves singing the song. And then when they were watching themselves, again, they were videotaped. That videotape is then shown to experts in emotion recognition coding. And these experts, they then code the amount of embarrassment and amusement that the participant displays while watching herself sing a karaoke song. And the results revealed that, as you might expect, that patients with BVFTD, they show less embarrassment while they watch themselves sing. And interestingly, also they also measured used physiological measures and measured heart rates, skin conductance, and so on. And also these were diminished, and this was associated also with the pre-metaphorium of the anterior cingulate cortex. The BVFTD is also very interesting for another issue, which is the evolution. That's actually last month, I think, this paper came out where they investigated. So the same group in UCSF in California, they correlated the maps of atrophy from a large cohort of FTD cases with the genes that are expressed in those particular brain regions. And then they investigated what the proportion was of those genes, so that code for the expression of the brain volume in those regions. There is a way to calculate what the evolutionary age is of those genes, or to say how much those genes differ from, in this case, the genes of similar genes in chimpanzees. And then they compared it to the entire set of genes coding for brain volume expression, and then they see that there is an increased proportion in the that's what they call human accelerated regions, so genes that code for genes that differ most from non-human primates that code for those particular expressions in brain volume. So actually, what I'm trying unsuccessfully, I think, to explain is that there is some kind of an effect of the evolutionary age of the brain regions and the the vulnerability for FTD. So the more evolutionary recent brain regions, they are more susceptible for FTD. And that is, so the study came out last month, I said, and so this gives you a link between the evolutionary age of the brain structure and BVFTD. And 2 years ago, we performed also the study where we looked at the functional age and the link between functional evolution, the evolutionary age and brain function and FTD. And so I'll try to explain this a bit better. So we presented phases, neutral and emotional phases into human subjects, neurotypicals, and fMRI scanner. And we used human expressions and we used primate expressions, and we showed these phases to human subjects and primate subjects. And what we found, actually we were looking for in the brain, are there regions that respond only to human expressions and not to other types of expressions. And then we found this region in the, we call this the right and middle superior temporal sulcus, which responded only to human expressions. And we did not find any region in the primate brain, so in the non-human primate, that responded either more to humans or to primate facial expressions. And our hypothesis is then that this is a more functionally evolutionary younger region developed in humans, and because we are primarily, we are the social species, the most successful social species. And then what we did later is we also used the same stimuli in the case of a cohort of FTD patients, and what we saw also there was first that if we compared the results of the middle STS with the posterior STS, which is also a well-known face area, and then we saw that there is more atrophy. So these are the controls, and these are the brain volume, and the gray ones are the FTD patients. And so we see that there is a reduced volume in the middle STS, but not in the posterior STS. There is no difference in looking at faces, at scrambles, but there is a difference in looking at human emotions in the middle STS, but not in the posterior STS. So this was a bit our research into the evolution and the FTD. Future directions that we are currently considering is there is quite some, there's a new hypothesis that the right temporal variant, so cases, FTD cases with primary atrophy in the right temporal lobe, anterior temporal lobe, that they constitute a distinct clinical phenotype, and Doga is also here. She is investigating this also with the paradigm, with the fMRI paradigm that I briefly discussed. And as you heard earlier today from Jesse, she is investigating the functional neuroanatomy of social cognition in pre-manifest FTD. So indeed, with the genetic cases, they have the advantage if we know that these persons, they carry this mutation, we can include them in our research before they start showing any symptoms, and that is what Jesse is doing. Lara, who's also here, she is investigating social cognition in the wild. You can talk to her for more details about that. But it's a bit addressing also what Arthur talked about this morning. One of the things that she's doing is that we are moving away from showing a face in isolation or a body expression in isolation. And we are combining that, or we are using actually naturalistic stimuli that combine congruent and incongruent emotional cues, so complex social scenes, just pictures taken from the internet, and just to see how well patients with BV-FTD recognize the emotional cues expressed in those stimuli. And then Aisha, who is also here, so we are well represented, I think, today. She's going a bit more deep. She's going a bit deeper in the social cognition deficits of FTD, and she's trying to link that to changes in interoception. And so one of the other features of FTD is that they have altered pain and temperature perception. And there is this one case of an FTD patient who he was living at the nursing home, and the nurses found him in a shower, which was with extremely hot water, and he didn't feel any pain whatsoever, and so they had to pull him out and took him to the hospital, and he passed away 3 days later, I think. So these changes in pain and temperature processing can be quite dramatic. But Aisha will reveal all the mechanisms related to that in 3 years, I think, when she finishes her PhD, right? And then she's currently in Peking, where she is investigating cultural differences in social cognition. And so, for instance, what we see, or the social norms are quite different between cultures, with the famous example of burping at the dinner table is very considered quite unpolite here, but in Asia it may be. Okay. I have to switch to the next part of my talk, but I think I'm quite there. So I hope that I have made you aware a bit of what actually a cool disorder BV FTD is, and how it can help us to gain more fundamental insights into the neural and behavioral basis of social cognition. It's primarily associated with then changes in the salience network, but also anterior temporal and frontal lobes, and a gateway to typically human characteristics. And then for the second part of my talk, I want to prime you a little bit. So I will show you a video in a minute of a patient that I saw. I was a postdoc, so when I still had time to do research. And first, I want to give you some background. As you may know, the mirror mark test is what is used, is one of the tests that may be used to assess self-awareness. And how it is performed is, here, this is also work by Frans de Waal. Oh, I'm happy that I can include him today. So a mirror is placed, this is in the case for elephants, but it has also been performed with apes or other species that are able to perform this task, or include apes, dolphins, magpies, and I guess the list will increase. But so what is done, how it's done is a mirror is placed in the cage, and then without the animal knowing, a mark is placed on a position that he's not able to see. And then when he sees himself in the mirror, then if he touches himself, it sounds a bit strange, but that means that he's aware that the mark is on his own body. And what you see here, for instance, these are the results. That here you see the proportion of times that the elephant touches himself when there is a mark on his head, or when there is no mark, but just a mirror, and when there is no mirror. So this is a bit how I want to prime you for the next video. Okay, so this is our attempt to do the mirror mark test in this patient. So he was actually admitted because she was convinced that somebody was living in her house uninvited, and the hypothesis was that this is based on a neuropsychological deficit here, in particular face or an on-face familiarity recognition deficit. Maybe in the further diagnostic work of this patient, we performed an EEG PET scan, which clearly shows here right lateralized temporal occipital, also inferior parietal hypometabolism. And actually, this patient was diagnosed with a posterior cortical atrophy, which is in 70%, around 70% of the cases due to Alzheimer pathology. So it's our hypothesis that this is was an atypical presentation of Alzheimer's disease. We also performed a categorical localizer fMRI experiment in this patient, and so what you see here is in blue we see the activation if we compare perception of bodies with perception of houses, and so this corresponds to the region of the right fusiform body area and right fusiform face area. So the white outline is the activation of control subjects is localized, and the red outline is the activation for faces versus house of healthy control subjects. And we see that we have face selective activation, but only in the left hemisphere, and body selective activation in the right hemisphere, where we see this extensive hypometabolism, suggesting that this self-awareness may be related to some hemispheric lateralization. And this type of misidentification symptoms, the dominant theory to explain this is the two-factor theory by Max Goldhart, where a misidentification is caused by both a neuropsychological deficit, so in this case a familiarity recognition deficit, but also, and so both have to be present, a deficit in belief evaluation, because the patient is not able to update the perception to the reality testing. And so that results then in a misidentification symptom or syndrome. I guess I'm relatively on time now, so I will end by thanking my collaborators, and especially PhD students who, of course, did all the work, who do all the work. Jazé, particularly Jazé Noga Hunden, Chihamlin, Van Tangji, and Laura van Hoven, and Aisha Mutashpour. Thank you.